Welcome to video. This video is going to cover about Le Chatelier's principle and some practice problems. Before start, I would like to provide one simple example for the better understanding of this concept. Imagine there's a person and imagine there's a money. If another person gives me a money, I would like to spend that money. However, if someone actually takes that money away, then I would like to make more money. This itself is Le Chatelier's principle, but in terms of chemistry, instead of this person, we're going to label as reaction at equilibrium. And instead of this money, we are going to label as a concentration or pressure or temperature. This Le Chatelier's principle is all about how the reaction responds to the change of its system. So in this case, 2 moles of hydrogen gas and 1 moles of oxygen gas is going to provide 2 moles of water gas, H2O gas. So first, we're going to talk about the change of the molarity, the change of the concentration. If I increase the concentration of hydrogen gas, the reaction now has a lot of hydrogen gas. So the reaction wants to consume that. Reaction now wants to decrease that increased concentration of hydrogen gas. So in this case, the reaction is going to shift forward. Using hydrogen gas as a reactant, we're going to produce more water gas. However, what happens if we decrease the concentration of hydrogen gas? Then, reaction now doesn't have a lot of hydrogen gas. So, the reaction wants to make hydrogen gas. So in this case, the reverse reaction would happen. We learned that the right side is going to be a product of the reaction. However, in this case, we're going to use water as reactant to produce hydrogen. So that being said, if we decrease the reactant, the reaction is going to shift towards the reactant. And if we increase the amount of reactant, the reaction is going to shift towards the product. It also works same for the oxygen gas, where if we decrease the amount of oxygen, decrease the concentration of oxygen, we want to make more oxygen. So again, we're going to use water, gas as a reactant. The reaction is going to produce more oxygen. On the other hand, if we increase the concentration of oxygen, the reaction has a lot of oxygen, and we want to consume that, and we want to decrease that oxygen. So, in this case, we're going to make more hydrogen gas. The reaction is going to shift forward. If we increase the concentration of H2O, now the reaction has a lot of H2Os, high concentration, so the reaction wants to decrease it and consume those high concentration of H2O. So in this case, the reaction is going to reverse and to produce H2 and O2. However, what happens if we decrease the concentration of H2O? So, now reaction wants to make more H2O because we don't have much H2Os. So in this case, the reaction is going to shift forward towards the product using H2 and O2 as a reactant. Now let's talk about changing the pressure. If pressure is increased in the system, the reaction wants to decrease the pressure. And on the other hand, if the pressure of the system decreases, the reaction wants to increase the pressure. How do we increase the pressure? Well, if you want to increase the pressure, we want to make more moles of gas. And if you want to decrease the pressure, we want less moles of gas. It is a similar reaction with the previous one, but in this case the product is H2O liquid but not gas. So first, you like to find how many moles of gas are presented in the side of the reactant and the product. So we have 2 moles of H2, which is gas. So 2 plus, we have only 1 moles of oxygen, so just 1. And in result, we have 3 moles of gas at the reactant. On the other side, at the product side, we don't have, so based on those information, let's see how the reaction will respond to the increase of pressure. If the pressure of the system increases, the reaction will decrease that pressure. So the reaction is going to towards the side where it has less moles of gas. So in this case, if the pressure increases, we want less moles of gas because we want to decrease the pressure. And comparing those two numbers, it is true that the product side has less moles of gas. So we can say that if the pressure of the system increases, the reaction tends to decrease the pressure. So the reaction is going to shift towards the product. However, if the pressure of the system decreases, now this reaction wants to produce more pressure. So in this case, we want more moles of gas. Thus, the reaction is going to shift towards the reactant where it has more moles of gas. Now let's look at another example. In this case, we have hydrogen gas and chlorine gas, and it forms 2HCl gas. So also in this case, we're first trying to find the moles of gases at each side. We have 1 moles of hydrogen gas, and we have 1 moles of chlorine gas. So in total, we have 2 moles of gas. On the other side, we only have 2 moles of HCl, which is gas, so we only have 2 moles. Wait, now those two numbers are same, so the pressure is not going to stimulate the reaction on the either side. Lastly, let's talk about the temperature change. The change of the temperature in the system. I like to say this temperature is quite related with concept of concentration, because if you treat heat as a product or reactant of the reaction, let's say we have an endothermic reaction, which heat is going to be a reactant and to produce something else. And the exothermic reaction is going to produce heat with something else. So, if the reaction is endothermic, we can say heat is a reactant. And if it is exothermic, we can say that heat is product. Now let's look at how reaction responds to the change of the temperature of the system. So let's look at endothermic reaction first. If the temperature of the system increases, meaning that we have more heat. Because we have more heat, this reaction will want to spend this heat to produce a product. So in terms of endothermic, if temperature of the system increases, the reaction will shift towards the product. If the temperature decreases, meaning that heat also decreases. And now, because this reaction doesn't have a lot of heat, we want to produce heat. So in this case, the reaction is going to be reversed and shift towards the reactant, meaning more heat will be produced after decreasing the temperature of the system. So now let's look at exothermic reaction. In exothermic reaction, heat is produced. So we can say the heat is product, right? So if you increase the temperature, meaning that heat is increased, because we have a lot of product and we have a lot of heat, we want to consume that heat. We want to use that heat to produce another thing. So in this case, the reaction is going to be reversed. It is going to towards the reactant and heat is going to be used. But if the temperature of the system decreased instead of increased, meaning that heat is decreased, now we want to make some more heat. So the reaction is going to shift towards the product and heat is going to be produced more. So now it's time for the practice problem. So stop the video and go ahead those practice problems and come back if you have an answer. Okay, so let's get the first question. It is a reaction between hydrogen gas, iodine gas, and it forms 2 moles of HI gas. So question A asks about what happens if more HI is added to the system at equilibrium? Meaning that HI is added, now the system will want to decrease those change. So now system will use HI to produce H2 gas and I2 gas. So the reaction will shift towards the reactant. So now let's get next question. What happens if pressure is increased to the system at equilibrium? Because we're dealing with pressure, I'm first going to calculate the amount of moles on each side, the amount of moles of gases. So we have 1 moles of hydrogen gas and 1 moles of iodine gas. So in total, we have 2 moles of gas. On the product side, or on the right side, we have 2 moles of HI gas, and that's it. So we have 2 moles of HI gas. And in this case, because those numbers are same, meaning that there's no more or less moles of gas at either side, so even though pressure is increased, this reaction is not going to be affected. So nothing will happen. So let's look at the next question. The question is the reaction between 2 SO2 and 1 oxygen gas, and it produces 2 SO3 gas. And the question asks, if temperature of the system raised and reaction starts to produce SO2 and O2, is this reaction exothermic or endothermic? So the concept you need to know is by figuring out is the heat product or reactant. And it gives a hint by raising the temperature and resulting in a increase of reactant, which are SO2 and O2. To produce SO2 and O2, which are reactant, we need to decrease one of the reactant or increase one of the product. But according to the question, it is stated that if temperature of the system is raised. So in this case, we can reason that it is not about decreasing a reactant, it is increasing a product, which heat is a product. So when you increase the temperature, heat is also going to increase. And because heat is a product, and we increase the amount of product, so reaction is going to shift towards the reactant, which is starting to produce SO2 and O2. So as soon as heat is on the side of product, this reaction is exothermic. So our last question, if HCl aqueous is added to the following solution, what will happen to the amount of the solid HCl? Hint, what ions are formed when HCl molecules dissolve in water? What ions are formed when HCl molecules dissolve in water? It's going to produce H plus ion and Cl minus ion. In this case, introducing HCl to the solution will cause increased concentration of Cl minus. So, as soon as Cl minus increased, and the reaction is going to shift towards the reactant. And as soon as our reactant is AgCl and is a solid, so we can say more precipitate or more solid AgCl will form. And this is it. Thank you.